Hello, in this video we'll be doing a quick introduction towards the plot function and other plot related stuff in MATLAB. So in MATLAB, you have the capabilities of creating really cool and really nice looking plots. And I will be showing you how we can do that. So to start with off, I'm going to show you the plot function. How it works, you simply do the plot. And as you can see right here, MATLAB is telling you, you first put in the X values and then you put in the Y values. So something like this. But first we need to put data, right? We can just put X and Y. So this is something, for example, a really nice template you can try out. X is equal to linspace. And I will explain a little bit what linspace is. And for right now, let's just do 0 to 10. Y is equal to X squared. And let's run this. I apologize, you have to put a dot right here. So right now you should be able to see the plot. So let's see what is going on here with what we wrote. So in the very first line, we see X is equal to linspace 0, 10. As you see in this plot function, the value starts at 0 and the plot ends at 10. So this linspace allows you to define a domain. So what does it do? Let's try it on the command window. This will help us visualize what's going on. Okay, so what's going on here, right? This is a lot of numbers. But if you look closely, you can see that it contains 100 values. Starting from 0, it slowly counts up until it reaches 10. And that is exactly what linspace does. So we do use the help command. Oops, I did a small typo. You can see right here it defines what linspace is. Linearly spaced vector, and it generates a row vector of 100 linearly equal space points. So the help command will be really useful for this class. So now that we have a domain that we saved into X, we can simply put in any formula that we want. In this case, I just chose X squared arbitrarily. And now we can plot it. So let's look back again at our plot. So as you can see, this looks very similar to the quadratic function. If, for example, I try for a linspace negative 10 to 10, and I run this, as you can see now it even looks like a quadratic. And it runs from negative 10 to positive 10. So what else can we do with these plot functions? The one thing is that we can customize exactly how our plots look like. And how do we do that? So first what you want to do is go to the command window and type in help plot. So right here, again, you can always use the help command to figure out what functions do. In this case, it tells us it plots a vector of y versus vector x. So again, our x in this case is just a vector that counts from negative 10 to 10. Our y vector is just using this vector and just squaring it. So now look at what it says right here. Plot x, y, s, where s is a character string. So remember strings from the video where we explain different data types, it just means text. Where x is text made from one element from any of the following 3 columns. And we see this table right here. So what does this mean? This helps us choose exactly how we want it to look. So this is how it would look like. You would just add a comma here. You would use quotation marks to make a string. So first we can choose the color. So we can choose between blue, green, red, cyan, magenta, yellow, black, and white. So let's choose magenta. If we want a magenta, all we have to do is just put the letter M because this is where it tells you. M for magenta. So I'm going to run this. And as you can see, our plot function is now purple or magenta. Let's try a couple of different colors. So let's try green. So for green, it tells us to just use the letter G. So that's what I'm going to do. And I'm going to click run. As you can see, it changes the color of the plot to green. Another thing we can change is how the line looks like. For right now, just ignore the second column. I will explain that one a little bit more. Let's look at the third one. So we can choose between a solid, dotted, dashed dot, dashed, or no line. So right now we have it as solid. So let's see what dotted looks like. In order for that to work, all we have to do is that after our color, we just have to add the colon symbol because this table is telling us for a dotted line, we use a colon. So I'm going to click run. And as you can see in our plot, it changed it to a green dotted line. Let's see what other options we have. We have a dash dot, so this one involves using a hyphen and then a period. So I'm going to click run. And as you can see in our plot, it now creates a dash dot. So let's look back at the second column. And if you're having a little bit trouble seeing it, I recommend that you open up MATLAB and type in help plot so you can see this table a little bit better. So let's say that instead of creating this, I have something else. Because remember, all plot does is just plots x and y based on two vectors. In this case, we create a domain using linspace. But let's say that we have data points like this. X is equal to 0, 2, 0, 1, 2, 3, 4, 5. So for example, let's say you finished the lab and you got some results and you want to plot it. And our values were 21.5, 30.6, 37.8, 48.9, 51.6. So these are just arbitrary numbers that I just made up on the spot. So let's see what happens when we plot these. So I'm going to click run. And what happened here? Oh, let me just remove the 0. So in order for these to work, these two vectors have to be the same length. So this one contains 5 numbers, and this one contains 5 numbers. So I'm going to click run. Ooh, so let's look at what's going on here. So as you can see, my first value is 21.5. And if we look at our first plot, the 1 is around 21.5. Our second value is 30.6. And if we look closely, our second value seems to match around 30.6. So it plotted my points and it just filled in the gaps with some lines. So let's change the formatting. So let's look back at the table. For color, let's choose black. So as you can see right here, K is for the letter black in the first column. So I'm going to change the G for a K. So now this is where we can use the second column. Instead of using lines, we can use symbols to represent our data. So let's use the X mark as an example. So for X mark, we just use the letter X. So I'm going to click run. And as you can see in our plot, we have the 5 data points we made from 1 through 5. But instead of having a line through them, it's just a symbol. So let's try other formatting. So for example, right here, we can see that we can use an asterisk for a star. So let's see how that looks like. And now we have black asterisks. So let's try a different color. Let's try red asterisk. So I'm going to change this K for an R because in our table, it tells us that R is for red. So I'm going to click run. And as we can see, the asterisks change colors. So now what if I want all 3 of them? I want a color, I want there to be starting points, and I also want the line between them. All we have to do is add all 3. So we will have color, data point, and I'm going to add a hyphen because that's for a solid line. So I'm going to click run. And as you can see, we have all of the three formatting options at once. So we have the color, the symbol, the line. So you can choose only one color, only one symbol, one line. So let's change this to a dotted line. Let's change it to, instead of asterisk, we have, let's try a square. So for a square, we have to use the letter S. So I'm going to change the asterisk for an S. And for the color, let's change it to cyan to see what it looks like. So I'm going to click run. And as you can see, all of our formatting options are now here. And remember, in order to find this table, all you have to do is just type in help, plot into the command window, and if we scroll up, we can see this table right here with all of these specifications. So now, what else can we do to these plottings? Here's a couple of other functions I want you to keep in mind. The first one is title. So all you have to do is just write a title and then pass a string. And remember, strings is just text in quotation marks. And then in here, you can just put in a title that you want. So for example, I can just write in any text that I want. And if I run it, it's now up here. A couple other thing that's also really important is the X and Y label. So X label, I'm just gonna fill in X label, and then I can do Y label, Y label. So let's see what happens when I run this. And as you can see, it added the X and Y label. And again, this can be arbitrary. Like for example, you could write in here time in seconds, distance in meters. And if I click run, it changes the X and Y labels. So this is really nice to have. A couple of other things. We can use the function grid on. And what this would do is that it will add a grid into the background. So usually this looks much nicer. So now let's say that we want to have multiple data inside this one plot. So I want to have this y value, so I'm going to call this y1. But there's also a y2 that I want to plot simultaneously. And for this one, it's going to have the values. Again, these are just going to be arbitrary numbers I'm making up on the spot. These 5 values. So how will I do this now? So let's say that, for example, your first reaction is to just say, well, I'll just plot my x, the first y values, and then I'll plot x and the second y values. But look at what happens when I run this. It all disappeared. Where did my title go? Where did my X label go? And why am I only printing one of them, not two of them simultaneously? The reason is because whenever you call a plot function, it will override all previous data. So how do we start from this overriding? We used hold on. Hold on. And I'm going to write it at the very top of my file. So whenever you have a script and you're going to be working with plots, this is what I always recommend that you start with. In your first line, you want to have close all, figure, hold on. So look at what happens when I run this now. As you can see, now everything is working. We have both of our lines, our title, our X label and Y labels, our grid, everything is here. So now let's add a legend because a legend is really important. So for that, we use the legend function. So for example, I could call this data set 1. So I'm going to write in quotation marks, comma, my data set 2. And again, this can be any string that you want. So for example, I'm going to run this. And as you can see, it changes the legend. And then from here, this is where we could, for example, put in our specifications. So again, going back to the table that you can find by typing in help plot, let's just add some color to this. So for the first one, I'm going to make it black. I'm going to make it have some X symbols, and I'm going to make it solid. For the second one, I'm going to make it red. So I'm going to do R for red. I'm not going to have any points, but I'm going to create it a dotted line instead. So for dotted, that's a colon. And let's run this. And as we can see, all of our data is here. If we want to remove the line and only have the symbols, all we have to do is just remove this. So for example, if I remove this hyphen and I click run, now it's printing the X for the data points, but it's no longer printing the line. So I do recommend for you to just plot arbitrary data and just mess around with the formatting. The formatting isn't anything too crucial that you have to learn, but it is nice for you to be able to print nice looking graphs. We want them to look fairly clean and professional. There's also one quick thing that I also want to notice, and I want to teach you how to use another way of plotting that is very similar. It's not too hard. And this one is using fplot. So what is fplot? It is very similar to plot, only except that if using vectors, we're going to use an anonymous function. So how does this look like? All we have to do is just create an anonymous function, which if you remember, to create an anonymous function, use the @ symbol, parentheses, I'm just going to call it x. And let's say I want to plot x squared. From there, in brackets, I'm going to specify the intervals. So let's say that I want to plot something from 1 to 5. So I'm going to click run. And as you can see, now we have this third line that is x squared and is plotted from 1 to 5. If you want to format it, it works just the same as plotting. So for example, if I want it to be, let's say the color blue, and let's make it a dash dot. So that will be a dash dot. Let's run this. And as you can see, it changed my fplot to this dash dot blue. So fplots are really nice whenever you have to print something like, for example, like a sine function or a logarithmic function, something that you don't have data points, because with fplot, you can just specify any function that you want. I could change this to sine of x, and I can change the intervals from 0 to 10, for example. So let's run this and see how it looks like. Okay, so if we look closer, so I can use the magnifying glass. Oh, magnifying glass. As you can see, we now have a sine function right here. So yeah, fplot is really good for whenever you want to plot an actual function and not just necessarily some x and y data points. For right now, I will conclude this for this plot video. I do recommend that on your own time you begin doing some experiments on plotting some random data points yourself. Get comfortable by using this table. It's definitely really tricky at first understanding like how to tinker with something, but once you get the idea, it becomes much easier. And remember, to generate this table, you go to the command window and type in help plot. So I really hope this video is useful to you. Plotting is something that you will be doing a lot in this class. And it's very important for you to be able to know how to create any type of plot. If you ever need any more help, you can always ask your professor, or you can go to the tutoring center where we offer tutoring for numerical methods in the science lab. So that will be it for this video. Thank you for watching. Goodbye.